This is the second day we're going to work on rational equations. There's not going to be a whole lot new, just a couple new things. Couple things I want to remind you about is that the solution to your problem cannot be a non-permissible value. So you always have to figure out the non-permissible values, and then once you get a solution, you have to check it back in the original question. In yesterday's lesson, we actually solved this question graphically, and we found that the solutions to this question were 0 and 2. So we're going to quickly do this question algebraically just to confirm that algebraically you do get the same solutions as well. Remember though, the first thing you do when you do something algebraically is you try to factor the denominators. In this case you can't. So the second step is you determine your non-permissible values, and if I look at this, I look at these two factors, our non-permissible values are plus and minus 1. So the third step is get rid of the fractions. So we're going to multiply every term by x plus 1 and x minus 1. So in the first term, the x plus 1's cancel out, and we're left with 3 times x minus 1. In the second term, the x minus 1's cancel out, and we're left with 1 times x plus 1. And don't forget that that 2 on the right-hand side has to be multiplied by everything. So if we start expanding things, we get 3x minus 3 plus x plus 1 equals 2 times x squared minus 1. If I combine like terms on the left side, I get 4x minus 2 equals 2x squared minus 2. If I move everything over to the right-hand side in this particular situation, we're going to end up with 0 on the left side, and we're going to end up with 2x squared minus 4x. And if you add 2 to negative 2, you're going to get 0. So the first type of factoring that you do is you try to take out a common factor. So we're going to take out a 2x, and you're going to be left with x minus 2. So we equate each of these things to 0. 2x equals 0, so x equals 0. X minus 2 equals 0, so x equals positive 2. And that does confirm the solutions we got graphically in the last lesson. Okay, so let's look at a couple more of examples. If we look at this next example, there's nothing that we can do to factor the denominator, but if we actually look at this and we determine the non-permissible value, x cannot equal negative 1. It's just that one value. Now, if we multiply each side of the equation by x plus 1 to get rid of our fractions here, on the left side the x plus 1's cancel out. So you're left with x squared minus 5x minus 6 equals 2 times x plus 1. Or if you expand this, you get 2x plus 2 on the right-hand side. So now we're going to subtract 2x, giving us negative 7x, and we're going to subtract 2, giving us negative 8. So if we factor this, two numbers that multiply to negative 8 and add to negative 7 are x minus 8 and x plus 1. Now if we solve each of these, we get x to be 8, and we get x to be negative 1. However, you have to check these solutions back, and you have to see that, oh, one of our restrictions is x cannot be equal to negative 1. So this potential solution that we calculated, it's not possible. We cross it out. It's not a possible answer. If you check 8 back in the original equation, it does work. Now, it says in part B, explain why one of the solutions to the quadratic equation does not satisfy the original equation. And that's because that solution is a restriction. So, let's look at two more questions here before we finish up this lesson. In this question here, you're going to notice x is in the denominator. So our restriction is that x cannot equal 0. Now we're going to multiply everything by x to get rid of the fractions. So x times x gives us x squared. These x's in the second fraction cancel out and we're left with plus 2, and 3 times x gives us 3x. So if we subtract 3x, we're going to end up with x squared minus 3x plus 2 equals 0. If we factor this, we get x minus 2 and x minus 1, and our values of x are 2 and 1. If that was a bit quick, stop it, go back, take a look what we did. Now we have to check these values back in the original equation. So we're going to start by checking 2. We're going to put it back in and we get 2 plus 2 over 2 equals 3. Well, 2 over 2 is 1 and 1 plus 2 is 3. So this checks out. The next one is 1 plus 2 over 1 equals 3. Well, 2 over 1 is 2. 2 plus 1 is 3. So both of these values check out. Neither of them is a non-permissible value, so they both work. Now, in this last example, before we can determine non-permissible values, we have to actually factor this difference of squares first. So that's x plus 2 and x minus 2. So if we now determine our non-permissible values, plus and minus 2 are our non-permissible values. So that's what we actually have to multiply both sides of the equation by, is x plus 2 and x minus 2, and x plus 2 and x minus 2. So on the left side, everything cancels out and we're just left with our numerator x. On the right side, our x plus 2's cancel out and we're left with 2 times x minus 2. When we expand this, we get 2x minus 4. If I subtract 2x from each side, I end up with negative x equals negative 4, or x equals 4. Now, 4 is not a non-permissible value, but we have to check 4 back in our original equation to make sure it works. So we get 4 over 4 squared minus 4 equals 2 over 4 plus 2. Well, this is going to give us 2/6 on the right side. This is going to give us 16 minus 4, which is 12, which is 4/12. Well, if I divide each of these by 2, it does give me 2/6. So the left side does equal the right side, and this does check out. And there we have it.